For controlling the robot's hand and legs, which one is more difficult?
Hands. And the reason is we can prove it. You already see robots dancing today, but you don't see any robots holding chopsticks.
Yeah, that's true. So holding the objects.
Holding is hard. Manipulating is difficult.
So do you think humanoid robot will be the next $1 trillion industry?
Without doubt.
各位曲博科技教室的观众朋友，大家好，我是曲博。又到了1年1度的 GTC 台北大会活动。我相信啊，在这个过去几年里面呢，人工智慧相关的应用可以说是雨后春笋，不停的发生。当然呢，这里面呢最重要的公司啊，就是辉达 NVIDIA。每年呢，辉达的活动呢都吸引了非常多的厂商参与。所有的观众们呢也都很好奇啊，到底最近辉达提供了哪些新的解决方案，让大家可以针对人工智慧有更好的体验。特别是啊，针对机器人这个领域，我相信大家都非常的兴奋。今天我们非常开心啊，邀请到辉达的 Spencer 总监来跟我们介绍机器人目前的发展现况。Welcome, Spencer.
大家好。
So, Spencer, we all heard of physical AI. So, what exactly the difference between physical AI and the chatbot?
A chatbot is the embodiment of an AI as part of a digital system. It's your digital companion, but it exists only inside of the computer. Physical AI is AI that has to be able to interpret the world. It needs to be able to see, perceive, right? It needs to look around and understand the world around it. And then it needs to understand and reason about what it needs to do in that world. And then it needs to act. And so physical AI has to actually interact with the world, and thus it needs to understand the world, meaning physics, the semantic relationship between different objects, different environments, and different tasks. And so physical AI is just an extension AI that we know today, and it's AI actually entering the real world.
So AI needs to understand the world,
yes,
right? All the physical phenomena in the real world.
Absolutely.
Another announcement is Agentic AI. So what's the difference between Agentic AI and the physical AI?
Agentic AI is actually a form of AI, but it doesn't preclude it from being physical AI. So Agentic AI is essentially an AI with a harness. It's a way for us to give an agent tools, the ability to have context, and the ability to have skills. And what that means is I teach an agent the tools it has, how to use the tools, and in what manner for the job that it needs to be done. And so today it's going to be on a computer helping you create documents, extract information, do analysis. But for physical AI, we can do the same thing. Agentic AI is going to help with physical AI because it allows us to have these self-activated systems. When you have agents, the work is constantly going. The computer is constantly working because you don't have to interact with the computer. Agent interacts with the computer. Agentic AI is going to help us accelerate physical AI because a lot of the work is humans having to manually tune either the physics parameters or understand, how do I extract information from the real world and then turn that into more data? How do I take that data and evaluate or train it into a policy? And then once I have a policy, how do I evaluate that policy in an environment? It's all very manual right now. And so Agentic AI is another way of having a set of workers that are going to help us with this along the way.
So these two kinds of technologies should work together to provide service for people.
Yes.
We know that NVIDIA provides a lot of software solution for customer or probably software tools for customer to develop their applications. For example, Cosmos 3 and the Issac Groot. What's the difference of this kind of tools?
Isaac Groot is it's a program in of itself. And so we've built a platform that allows humanoid developers to be able to go from simulation all the way to real, whether it's data capture, data synthesis and augmentation, simulation, evaluation, and then deployment. Cosmos is a world model, and now it's a world action model. What's important is that when you think of Isaac Groot, the VLA, it was really started with a VLM, a vision language model, and then we added an action head to. And then the reason for us to start there is because a VLM understands the world semantically, but it understands the world through pixels. Cosmos, on the other hand, allows us to understand the world with vision and with action, because robots have to interact with the world in action. And so these world action models, such as Cosmos 3, become the backbone, the underlying foundation for the next generation of Groot. What this allows us to think of, we start with models that allow us to explore the world given the technology that we had in order to understand where the gaps are. But where we started with VLA is not where we stop. Just like as we're heading into world action models, we don't know what the next architecture might be. And so we're still on this journey. But what Cosmos 3 gives us is physical realism, because there are two types of simulators. You have Omniverse, which is a conventional simulator, extremely high fidelity, very, very high fidelity physics and grounded, but it's very hard to create many, many environments because you have to manually do it. Humans have to do it. On the other hand, you have Cosmos, which is able to generate all sorts of with novel environments, new scenarios, new tasks, things that we've never been able to either simulate or we didn't have enough time to be able to bring in the environment. However, these world models, because they're learned, the physics is not as accurate as you would have in a conventional simulator. And so both of these need to be used in conjunction with each other, because in order for the Cosmos world model to become more and more physically accurate, you need much more physics data. We already have trouble capturing real data, and we need to have synthetic data. So Omniverse, a conventional simulator, gives you lots of data that's ground truth, and we can bring it over into Cosmos in order to pre-train it, so that way it becomes more and more accurate. Cosmos is used for three things. The first is synthetic data generation. We need to be able to have new environments, new scenarios, and we call new verbs. You want to use language or action to prompt a new scenario or prompt a new data set. The second thing that you're going to use it for is for policy evaluation. Once I train a robotic policy, I need to evaluate it in millions of different scenarios, ideally, but it's too hard to do that manually. And so using a world action model allows us to do this because it gives you plenty of flexibility. On the third is going to be these policies, or these world action models actually can become the policy, because RGB vision and action are first-class citizens. And because of that, it can actually output action as well. Now, the way that we use it for Groot is Cosmos 3 is really underlying Groot. And so we can build on top of Cosmos. And so Cosmos and Groot are really a bit of a stack more than they are next to each other, right? So Cosmos at the bottom, and then you have Groot on top.
So if a customer want to develop a robot, they got to use both of these tools, right?
They can. Yeah, you can use any tool that we give, any technology we have, you're free to use where you need it, when you want it. The reason why I say this is because the research is still brand new. There's wonderful research happening in extending the VLA architecture to include tactile. And so you might hear it as VLTA, vision, language, tactile action. On the other hand, there's another camp where they're going towards these world action models. And so it's end-to-end RGB with action. Both of these, I think, are interesting paths. And in the near term, there's no guarantee that one or the other is going to, be the winner. And so we want to make sure that we create the platform and the technology so that way both fields are able to progress by themselves, because there's so many things for robotics to solve. It's impossible that one thing can solve it all today.
Yeah, sure.
Yeah.
So I think your tools help customer to develop their product easier.
Yes. We can't make robotics any easier, but hopefully we can make it simpler. Easier for developers with PhDs, but we still need PhDs to solve the hard problems.
Yeah,
but luckily, the new technologies, especially agents, mean that you don't have to have a PhD to start in robotics. And so we're definitely in a brand new world.
For large language model, if it generates a wrong answer, it will not be a serious problem. But for a robot, if it make a wrong decision, it could cause serious problem. So should we give a higher standard for robot?
The way to think of general robotics is we've been doing autonomous vehicles for over 10 years. Autonomous vehicles, their job is to go very fast around humans. And so they have to be extremely safe. It has to have graceful failover, absolutely needs functional safety. The thing with autonomous vehicles is they spend their whole life trying not to touch anything. And general robots are here to spend the whole life touching things just right. And so the degree of safety is definitely increased. We need to make sure that these robots are able to reason about the environment. If you look at Alpamayo, it's the first model that's able to reason about intent inside of the environment. If a ball goes across the street, maybe a child is coming after it. For a robot, it's going to be very similar. As we work in the environment, I actually need to not only understand causality, but I need to understand intent. What do I think you're trying to accomplish? And so I can break down that task and understand, how do I not get in your way? Or if I'm doing something and I see you coming across, is okay, well, where do I think you're going? So that way, if you are going to cross over, how do I make sure that I'm safe? And so physical AI absolutely needs to be it has to be more stringent in its safety, its functional safety, its physical safety. LLMs have their own safety. We call them guardrails. And so guardrails become part of the models for physical AI, but we also need to have physical safety measures that are built into the onboard system, as well as to be around all the models and all the physical systems themselves.
I think the safety of the autonomous car should be more important than a robot, right?
For today, it is.
Yes.
And the reason is because autonomous vehicles are here today. But imagine in the future, in just a couple of years. Right now, we see robots in factories. And so if I want them to be safe, I put humans in another space. The safest robot is one that's in a different room. But we want robots to be around us in society, helping us in the home. And if you want them in the home, they have to be actually even more safe, because they're not moving at high speeds in a structured environment. They're working in unstructured environments, and they have to work at speeds that are safe for humans as well as for the robot itself. And so it's today, you're absolutely correct, but we need to start the conversation and we need to start thinking about how to build functionally safe robotic systems today, so that way tomorrow they're ready.
So another interesting question is the humanoid robot. When will it come true? I think most people want to know that.
I think personally, there's two types types of humanoids. When you think about it, humans built the world with their hands, not with their feet. And so the most important part is actually the two hands. But in order to navigate a really hard environment, 2 feet are necessary because wheels aren't going to get you everywhere. So I believe that if I make that distinction, then I could say that wheel-based humanoid types, these mobile manipulators, will be seen in the next few years. In fact, they're going to be seen, already today at the end of the year, doing limited but useful tasks. Biped humanoids, a little bit further away. And the reason is because the environments that we expect them to go into are a lot more diverse and a lot more unstructured. When you think of restocking 7-Eleven, you don't need 2 legs for that. It's okay to have wheels because it actually needs to carry heavier things. And so you need to be more stable. When you go into a house, wheels become troublesome. Yeah. You need legs. If you're like me and you have a dog, I have lots of toys on the floor. Wheels aren't going to work. You got to walk around those toys. And so it's very important for us to create a distinction there. But humanoids are coming, but they will come in phases. And so when I think that the question you're asking is, when do we think that truly generalized humanoids will come into our life? And I think we're only a few years away from seeing the first version. It's coming soon.
It should start from the factory, right?
Absolutely. It starts with the factory because a factory is semi-structured. What we're trying to do is robotics is hard, as you know. And because robotics is hard, almost nothing works out of the box. And we need to find environments where we can create conditions for success. And manufacturing and warehouse, they allow us semi-structured environments. They're relatively the same between different companies and different regions. The types of things you see are pretty common. They're shared among the same environments. And the tasks they're doing are relatively similar. And so that's why we'll see them in warehousing, we'll see them in manufacturing, we'll see them in data centers. We might even, we'll see them in hospitals because the types of work that they're doing in hospitals, very similar to a warehouse. Moving materials between wings, trying to go and fetch objects. These are all things that we can start deploying in the near term.
So do you think humanoid robot will be the next $1 trillion industry?
Without doubt. And the reason is because, humans built the world in our image. We built them for humans. We didn't build them for, 4-wheeled robots or 4-legged robots. We built them for 2 legs, 2 hands, and a human-sized height. So the next generation of environments is going to be designed for robots, but it doesn't mean that we can rebuild everything that we've spent many years building. And so we need robots that can come into our homes. They can go into existing factories, existing environments, and they're also going to need to fit and use all the tools that we've built for humans. And so humanoid form factor makes absolute sense. But while we're trying to solve for autonomy, the brain, we're going to be solving for some tasks that may not need humans necessarily. They might be too heavy, too dangerous, too dirty, and that's helping us get to the skills. But ultimately, the humanoid form factor is absolutely going to be the ultimate form factor.
For controlling the robot's hand and legs, which one is more difficult?
Hands. And the reason is we can prove it. You already see robots dancing today, but you don't see any robots holding chopsticks.
Yeah, that's true. So holding the objects.
Holding is hard. Manipulating is difficult. Being able to use dexterity. And for instance, the hardest thing is actually 2 hands manipulating the same object. I can have one hand do this. I could have another hand do this. But you haven't really seen robots where they're doing this. And that's because these are the hardest tasks. Insertion tasks, assembly tasks. These are all things that is human level dexterity. Super hard to get to that. Locomotion, on the other hand, it's not fully solved, but we're much further. And the reason is because we've been studying that for so many years. And we needed more technology to solve for manipulation than we did for, whole body control in terms of walking. So that's why you see so much improvement on whole body control, and why manipulation, it seems like, we're making slower progress, but truly we're making great progress because the fundamental problems are so challenging. We have to solve for physics in simulation because you have to do soft body, rigid body dynamics. And so we have to build the system to model the physics. Tactile. We have to build technology for the robot to be able to touch. We have to build hands that are small enough to use human tools and strong enough to be able to do things that are superhuman. The dynamics and the requirements of manipulation are greater than mobility.
今天我们非常感谢辉达 NVIDIA 的 Spencer 总监接受我们的专访，谈人工智慧，特别是人形机器人相关的应用。大家有任何相关的问题，欢迎大家发表在影片的下方，我们再来讨论。谢谢大家，晚安，拜拜，
拜拜。